All right, so we spent some time talking about exponential functions, how they look, how the points kind of behave. So we're going to compare exponential functions to the other type of functions we've spent a lot of time talking about, and that's linear functions. So this example, this Regents question, Alicia has invented a new app for smartphones that two companies are interested in purchasing for a 2-year contract. Company A is offering her $10,000 for the first month and will increase the amount each month by $5,000. Company B is offering $500 for the first month and will double their payment each month from the previous month. Monthly payments are made at the end of each month. For which monthly payment will Company B's payment first exceed Company A's payment? All right, so this question is a good question to compare and contrast the different ways the money's growing. So I set up a couple tables here. So Company A is starting off with 10,000 for the first payment, and they're increasing the payment by 5,000 each month. So for the second month, it would be 15,000. Third month is 20,000, 25,000 for the fourth month, 30,000, and so on. So I'm going to keep on adding $5,000 to the previous payment each month. And then for Company B, their first payment is $500. All right, so it seems pretty small compared to the 10,000. And they're going to double it. So the second payment would be doubled to 1,000. And then 2,000, 4,000, 8,000. 16,000, 32,000, 64,000, 128,000, and 256,000. So as you can see, the right side, Company B, their payment goes up quickly because we're doubling these numbers. And the question they asked was, for which monthly payment will Company B's payment first exceed Company A's payment? So we're looking to compare these numbers, and it looks like the first time that B is higher than A is the eighth payment. But I like the comparison. If you think about what's happening, this is going up by a constant amount. Whereas on the right side, this company is doubling. So even though it starts lower, it catches up pretty quickly, and then it goes well past it. So it's 64,000 compared to 45,000. The next month, it's 128,000 compared to 50,000, and then 256,000 to 55,000. That's $200,000 more. So we spent a lot of time talking about linear functions. We talked about the slope and the y-intercept of the linear functions. So that is our standard form that we usually think about: y equals mx plus b. M is the slope, b is the y-intercept. So in our equation, y equals 2x plus 5, we know the y-intercept is 5. And the slope tells us how much the points would increase. So if the x goes up by 1, the y should go up by 2. That's based on the slope. But exponential is a little different. So exponential functions, we have our standard form y equals a times b to the x. A is still the y-intercept. That's still going to be the initial value, the starting point. B is what we call the growth and decay factor, and we talked about what kind of numbers would get growth and what would get decay in the last lesson. So our first example here, y equals 5 times 2 to the x. The y-intercept is 5. But we don't add 2 every time. Instead, we're going to think about multiplying by 2. That looks like too much like a plus for me, so I'm going to, there we go. And if you think about what this equation's doing, if you put in a value of x, that's the exponent. That's how many times we're going to multiply by 2. So for that exponent where x is 1, 5 times 2 is 10. When the exponent is 2, we multiply 2 times 2. 2 times 2 is 4, times 5 is 20. So we're adding another 2 every time because that exponent's getting larger. All right, so we're going to start slow here. We're just going to talk about whether these tables represent linear functions or exponential functions. So we're looking to see, is there a constant increase or decrease, or is it a multiple of the previous number? So if we take a look at the first table, the x's go up by 1, the y's go from 6 to 18, which would be an increase of 12, and then from 18 to 54, which is an increase of 36. And then from 54 to 162, that's an increase of 108. So definitely not a constant rate of change. So this is going to be exponential. Now, if we think about what the growth factor is, 6 times what is 18? This would be times 3. And if you checked it out, 18 times 3 is 54, and 54 times 3 is 162. So if you go to the right side here, x is going up by 1, 3 to 8, that's an increase of 5. 8 to 13 is an increase of 5. 13 to 18 is an increase of 5. This is linear because it's at constant rate of change. So take a minute, try the bottom two, see if they're exponential or linear, and then restart the video and see if you got the right answer. All right, so on the left side, the y values are decreasing by 9 every time. So that would be a linear function because there's a constant rate of change. On the right side, there is no constant rate of change. It goes down by 48 and then 12 and then 3. So this has got to be exponential. And if you think about what would multiply by 64 to get 16, I know it seems a little bit tough because it gets smaller, but it's going to be times 1/4. We'll talk more about how to get that number shortly. All right, so we want to figure out the equation of an exponential function. So we want to be able to write an equation to match the table, a graph, whatever we have. So we need our standard form of an equation or an exponential function. We need the y-intercept and we need the growth or the decay factor. And we're going to check with our calculator, so we have that handy. So if you look for the y-intercept, we're looking for when x equals 0. In our table, we can see that when x equals 0, the y is equal to 8. So 8 is our y-intercept. So let's talk growth factors. Some are easy to pick out. This one I don't think is too bad. If you go from 2 to 8, 8 to 32, 32 to 128, we're thinking what number do we have to multiply by to get from each uh, column to the next? And this would be a growth factor of 4. How do we figure that out if it's not obvious? Well, we're going to work kind of backwards. So if you divide 128 by 32, we get 4. If we divide 32 by 8, we get 4. If we divide 8 by 2, we get 4. So I'm kind of working from right to left, backwards division to see what I have to multiply by, because division and multiplication are inverses. So this shows us that the growth factor is 4. So if we put this all together, our equation is going to be y equals 8 times 4 to the x, or you can write it f of x equals 8 times 4 to the x. And I just want to double check with my calculator. Put that in and go to the table. And when we had negative 1 with 2, 0, 8, 132, 2, 128, those are the values we had in the table. All right, so another function, we want to figure out the equation. We're looking at the same important parts. The y-intercept when x equals 0, in this case y is equal to 12. And this time it's asking for the decay factor. And if you look at what's happening to the numbers from 36 to 12 to 4 to 1.3 repeating, they're going down. So when we talked about decay factor, the number has to be between 0 and 1. So we're thinking a fraction. Not all fractions aren't between 0 and 1, but this one should be because it's decay. So I'm going to work backwards again. I'm going to divide, and that first one's going to be a little tough. But the other two shouldn't be too bad. So I'm going to start with the two easier ones. 4 divided by 12. I can divide both those by 4. And we end up with 1/3. And if I divide the last fraction both by 12, we get 1/3. So I'm going to use my calculator for that first one. If I divide 1 point, and I'm going to put some 3's in, divided by 4, we get a decimal that turns into 1/3. So this decay factor is 1/3. So if we put everything together, our equation is y equals 12 times 1/3 to the x, or g of x equals 12 times 1/3 of the x. And I'm going to go check with my calculator just to make sure. So negative 136, 0, 12, 1, 4, 2, 4 over 3, which is 1.3 repeating. All checks out. All right, so I want you to stop the video, try to find the equation of each table on this page. And again, you're looking for the y-intercept, the growth or decay factor, and definitely check using the graphing calculator whether the tables match up. And then restart the video and see if you got the right answer. So for the first table, I got y equals 10 times 5 halves to the x power. So I divided all those y values to see what was happening, and they were going up by a factor of 5 halves. Y-intercept is across from 0, so 0, 10. Number 2, the y values are going down, so we're thinking decay. 24 divided by 36, 36 divided by 54, 54 divided by 81, all simplifies to 2/3. And the y-intercept is 54, so y equals 54 times 2/3 to the x. Number 3, I got the growth factor to be 4/3 and the y-intercept to be 36, so 36 times 4/3 of the x for g of x. And then for the last one, the h of x values are decreasing by a factor of 1/5. The y-intercept is 25, so h of x equals 25 times 1/5 to the x. All right, so similarly, we're going to figure out the equation of graphs. And so we're going to kind of treat it the same way. We want to get some points, especially the y-intercept. So in this case, it looks like the y-intercept is 24. And I need 2 points, at least 2 points. 3 is preferable. That way I can have kind of a check. But I need a few points to figure out what the growth or decay factor is. So this point is negative 132. And this point is 118. So I like to set up a small table just because that's what we're comfortable using. But we don't really have to. It's just a way of organizing it. But once we have those points, now it's similar to what we just did. So if I have 18 divided by 24, or 24 divided by 32, those both are going to simplify to 3/4. And our y-intercept is 24. So we're looking at y equals 24 times 3/4 to the x. And let's check that with our calculator. All right, and our graph the window is not set up how the original graph was. So the original graph goes up to at least 60, and it's going by twos. It doesn't really drop down too far in negatives because it doesn't cross the x-axis. So I'm going to change my window just a little bit. I'm going to go up to 60. I'm going to jump by 5s because our screen's a little smaller. But if you trace 0, 24, negative 132, 118, everything matches up. All right, so we got 2 more graphs that we're gonna try to find the equations of. So I'm gonna look for some points. Looks like the first point is 0, 2. The next point is 1, 6. And the next point is 2, 18. So the growth factor is 3. 2 times 3 is 6. 6 times 3 is 18. The y-intercept is 2. So this equation should be y equals 2 times 3 to the x. Down to the bottom graph again, I'm going to look for some points. Based on the shape of the graph and the direction of the y values, this is going to be exponential decay. And 8 over 12, 12 over 18, they're both are going to equal 2/3. With the y-intercept being 18, this equation should be y equals 18 times 2/3 to the x.